Assalamu alaikum dear students. In this lecture we are going to find the maximal ideals of Z8, Z10, Z12 and Z36. Before discussing the maximal ideals, we discuss some important terms. For each positive divisor D of n, the set generated by D is a unique subgroup of Zn, and this is subgroup of under addition, and its order is n by d. Further, please note that if d divides n, then obviously there is some quotient q, n equal to, we can say, qd. Then D generates a subgroup of Zn. Obviously it is an ideal and its order is n by d, and Q also generates another subgroup of Zn and its order is n by q. For example, in Z10, divisors of 10 are 1, 2, 5 and 10. 2 divides 10. There is an ideal and subgroup generated by 2 of order 10 by 2 mean order 5. Similarly, ideal generated by 5. This is another ideal of Z10 and its order, it will be 10 by 5 order 2. For ideal generated by 2, its order will be 5. Ideal generated by 5, its order will be 2. And these both will be additive subgroups and also ideals, and these are principal ideals. Before finding the maximal ideals of Z8, Z10, Z12 and Z36, first I would like to define what is maximal ideal. Let R be a commutative ring, then an ideal M is maximal ideal of R if M is contained in R and there is no other ideal in R which contains M. R and M, there is no ideal between R and M. Now we suppose N is an other ideal between M and R, and if M is maximal ideal, yani mean ke N is an other ideal containing between M and R, and M is maximal if M is equal to N, R, N is equal to R, N will be either R or N will be either M, then M will be maximal ideal. Further note, every principal ideal is not a maximal ideal of Zn. Principal ideal may or may not be maximal ideal. Please note it. Lastly, if cyclic subgroup generated by A, then its elements will be E, A square, A power 3 and so on up to A power n minus 1 is a cyclic subgroup under multiplication. cyclic subgroup cyclic subgroup under addition, then its elements will be of form cyclic group under addition. Additive identity, we know it is 0, then A, and now A will be added, it will become 2A. Here A in multiplication, A square, here 2A, 3A, and so on up to n minus 1 A times will be added. Please note, this is the ideal or subgroup under addition. Elements will be added in this form, but in multiplication it will be multiplied. This is the difference. We will follow this technique to find the maximal ideals of Z8, Z10, Z12 and Z36. Now we find the maximal ideals of Z8. Z8 will contain 8 elements: 0, 1, 2, 3, 4, 5, 6 and 7. But first we find the divisors of 8 are 1, 2, 4 and 8. 1 divides 8, so ideal generated by 1 is the identity, and we know it is the ring itself or Z8 itself. If our ring is Z8, then ideal generated by 1 and its order will be n by d. N by d mean 8 by 1, 8 elements, and Z8 it contains 8 element. Next, 2 divides 8, so ideal generated by 2 will be of the form 0, 2, then because this is additive group, 2 will be added, it will become 4, then 6, and 8 divided by 8 it will be 0. It is ideal generated by 2 is of this form 0, 2, 4, 6, and its order is 8 by 2, 4 order of this. Next, 4 divides 8, ideal generated by 4, 0 and 4, it contains 2 elements, order is 8, n by d, n by 8 by 4 order will be 2. These are 2 elements. Next, 8 divides 8 and ideal generated by 8, it contains, its order is 8 by 8, 1, its order is 1, and order of 1 it is identity group or identity additive identity, it is 0. These are 1, 2, 3 and 4 ideals of Z8. Now we have to find which is the maximal ideal of Z8, and note that 2 ideal generated by 2, it contains ideal generated by 4. Every element of 4, 2, 0 and 4, it is in the ideal 2. So 2 is the bigger, larger element ideal, and 4 is contained in 2. And it also contains ideal generated by 8 or unit element. 2 is contained in Z8 and Z8 is generated by 1. 1 is Z8 or ring itself. And from this we can conclude ideal generated by 2, this is the maximal ideal. So the maximal ideal of Z8 is the ideal generated by 2. We can also sketch the diagram. This is Z8 are generated by 1, or this is R. This is the ideal generated by 2. This line is generated by 2 and generated by 4 this and this is the ideal generated by 8 are identity elements smallest. 4 and 2, this is the maximal ideal between R and this is 2, 2 is the maximal ideal. In Z10 it contains 10 elements 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 and divisors of 10 are 1, 2, 5 and 10. 1 divides 10, so ideal generated by 1 it is Z10 itself or R. 2 divides 10, its elements will be of the form 0, 2, 4, 6, 8 and its order will be n by d. This is the order. N is 10, 10 by 2, order is 5 and these are the 5 elements. Next 5 divides 10, ideal generated by 5 it will contain 2 elements 10 by 5, its order will be 2, obviously 0 and 5 and finally 10 divides 10. This is the ideal generated by 10, obviously identity elements and because order of 10 by 10 is 1. 1 is the unit group and unity, this is the unit ideal. These are 4 ideals 1, 2, 1, 2, 3 and 4, 1, 2, 3 and 4. Here the maximal ideals are 2 maximal ideals. Ideal generated by 2 is the maximal and next ideal generated by 5 is the maximal ideal. In Z10 these are 2 maximal ideals. In Z36 0, 1, 2, 3, 4, 5, 6 and up to 35 are the 36 elements of Z36 and the divisors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. These are the divisors of 36. Now we find their subgroups or ideals generated by these numbers. Please keep in mind the same procedure. 1 divides 36, so ideal generated by 1 it will be Z36 itself or ring R itself and its order is n by d. 36 by 1 order will be 36. 2 divides 36, so ideal generated by 2 its order will be 36 by 2, 18. There will be 18 elements in this ideal. These are 0, 2, 4, 6, 8, 10 up to so on up to 34. These are the elements of ideal generated by 2. These are 18 elements. Similarly 3 divides 36. 2 divides 36, order 18. 3 divides 36, these are elements are 3, 6, 9 and its order will be 36 divided by 3 mean 12. These are the 12 elements. 4 divided by 36, its order will be 9. 36 by 4, its order is 9. These are 9 elements 0, 4 up to 32. 6 divided 36, its order will be 6. 0, 6, 12, 18, 24 and 30, order will be 6. It's 6 is the order. 9 divides 34, 0, 4, 0, 9, 18, its order is 4 and 12 divides 36, order will be 3, 0, 12 and 24 are elements. 18 divides 36, it is of order 2, 0 and 18 are the elements. 36 divides 36, its order is 1 and one order its ideal is obviously unit or identity, that is 0. Now please have a screenshot of this page. The ideal 2 generated by 2 0 2 4 6. From this, note that ideal 2, it contains ideal generated by 4. Every element of this ideal is in ideal 2. Further, ideal generated by 12, this is also contained in ideal 4, and 4 is contained in ideal 2. Please note that every element of 0 12 0 2 0 12 and 24, it is also in ideal 4, and ideal 4 is in 2. We can say this is series. And again, obviously ideal 2, it is contained in ideal generated by 1, and 1 is Z36. Another thing, ideal generated by 2, it contains ideal generated by 6. Every member of 6 is also in ideal 2. 0 6 12 18 up to 30, this is also contained in 2. And it also contains ideal generated by 18. 18, 0 and 18, these are two elements are contained in ideal generated by 6 and ideal generated by 2. Please note this, these two series mean 2, in these elements 2 is the maximal ideal. And from this discussion, we can say ideal generated by 2 is the maximal ideal, and ideal generated by 3, it is also maximal ideal. 2 and 3 are the maximal ideals of Z36. Now we find the lattice of ideals of Z36. Z36 and its maximal ideals are 2 and 3. These are the maximal ideals. Next, 6 is contained in both ideal 2 and both ideal 3. So this is the ideal 6. But 4 is contained in ideal 2 only. This is 4. Further, 12. 12 is contained in ideal 4 and ideal 6. 6 contains ideal 12 and 4 also contains ideal 12. 9 is contained in ideal 3. 18 ideal, it is contained in both 6 and 9. And 0, this is the unit identity ideal or identity subgroup. It is contained in 12, 18 and obviously all ideals, and this is the lattice of ideals of Z36. And from this we can also conclude 3 is the maximal ideal and 3 is the maximal and 2 is the maximal ideal of Z36. I hope you can find the maximal ideal of Z10 of any number. Further note that Z10 is a maximal ideal if n is a prime number. Please subscribe and share if you like. Thank you.